And welcome back, and it's the 5-a-day further maths, and let's just crack on with the first question, shall we? Okay, so what do we have first of all? So James is creating 8-digit code to lock his iPad, does not repeat any digit. Okay, so this is a combinations question. Now, notably, we're going to make an assumption here because a real exam question would say this really clearly. I'm going to assume that it can be a number that starts with 0. You have to be careful normally, but I think that's fair in this case because passwords can start with 0. So I've got 8 digits, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Missed one off the end. There we go. 8. Does not repeat any digit is clearly the key here. If you can repeat digits, then it's 10 times 10 times 10 times 10, 8 times. Okay, so let's think about what he's got. So this first digit can be any one of 10 different choices. Then the next one is to use the digit up because it's not repeating it. So that's 9 choices, 8 choices, 7, 6, 5, 4, 3. So in other words, now there's a couple of ways to do it. I can just work that out 10 times, 9 times, etc. Or get my calculator out and I could do 10 factorial divided by 2 factorial because I don't want the 2 and the 1 at the end. And if I do that now, so I get my calculator out, I get 1814400. So in other words, 1.8 million, bit more than that. Good question. Next one. Okay, so we've done a few of these so far, haven't we? So show that f 2x minus 3 is a factor of this function here. And I'm going to start by saying that's equal to f of x, because that allows me to sort of round my conclusion up nice and neatly. Then I'm going to work out f of 3 over 2. In other words, when this equals 0, x equals 3 over 2. And that's going to give me, now, because it's a show that question, I don't actually have to write it all out, but I do need to show what I'm doing. So let's do that. So it's going to be 2 times 3 over 2 cubed, which is 27 over 8, plus 9 over 3 over 2 squared, which is 9 over 4, minus 32 times 3 over 2, plus 21. Now, look at the number of marks in the question. If there's just 2 marks, that's probably enough. Just write equals 0. Check it on your calculator that you're correct. If there's 3 or 4 marks, which there won't be, then at least another line of working. So I'm going to say that's 27 over 4 plus 81 over 4 minus 90, well, divided by 2, isn't it? So 16 times 3 is 48 plus 21, and that does indeed equal 0. Then you need your conclusion. Answer the question as f of 3 over 2 equals 0 by factor theorem. Therefore, 2x minus 3 is a factor of f of x. And done. Conclusion, explanation, question answered. Next question. Okay, okay, I've just realised what that says. That's an I, isn't it? So this is 14i. Well, I is 1001. So in other words, this is 140014. So I should say this, as in all of this together is 140014. Now thinking about it, I actually don't need to do the whole thing, do I? Because all I need to do is that times that, which gives me this. So I can do this in one line. So it's going to be 5 times minus 2 minus 4 times m is equal to 14. Okay, so let's just expand this. So I've got minus 10 minus 4m equals 14. Add 10 to both sides, is going to be 24. Divide by 4, we've got a negative as well. Let's do it so we don't make a silly error. So it's going to be minus 4m equals 24. Minus, divide by minus 4, and m equals minus 6. There we go, we got there eventually. M equals minus 6. Nice question. What I like about this question, and it's a good example of something, is don't do more than you need to. I didn't need to expand the whole thing. I just need to observe. I need to expand one row and one column. Done. Next one. Solve the simultaneous equations. Well, there's a few of these this month, isn't there? Right, I'm going to do my usual. Let's label that 1 and let's label that 2. Now, because I've got a y equals here, I'm going to rearrange this one. So actually, no, I'm going to do something different. What I'm going to do is I'm going to write down 2 times 1, which is going to be 2y is equal to 2x squared plus 2x minus 14. And then I'm going to rearrange equation 2. So it says 2y is equal to minus 1 minus 4x. And it must be the case that this is equal to this. So I can just say minus 1 minus 4x is equal to 2x squared plus 2x minus 14. Let's do some collecting. So 2x squared. Add 4x to both sides is going to give me plus 6x. Add 1 to both sides is minus 13. Okay, this won't factorise, will it? And that's it. Yeah, this won't, 2x squared, sorry. And this won't factorise. So I'm going to have to use a quadratic formula, which means that x is going to be minus 6 plus minus a square root of 36 minus 4. Minus is a plus, so plus 4 times 13 times 2. Well, this is really messy, so let's do this carefully. Divide that by 2 times 2, which is 4. I'm going to get my calculator out. What I'm going to do, just for space reasons, is, well, let's do the step in between. So that's going to be minus 6 plus minus over 4. If I get my calculator out, that is, it tells me it's 2 root 35. So 2 root 35. Now, I'm just going to write these down because I'm going to have to do a little bit more work, aren't I? So if I work the first one out, that tells me that x equals 1.458. If I work the second one out, so change plus to a minus, that means that x is equal to minus 4.458. So I've got my x's. We've got there with the first bit, but I also need my y's. Now, having said, I thought I was being quite clever at the start, I still need equation 2 to be y equals, don't I? So let's write this down here. Now, I'm doing a really bad job of what I tell everyone not to do in my class, which is make sure your working's nice and clear. So I'm going to show equation 2 can be rewritten as y is equal to a half of minus 1 minus 4x, because I'm going to have to use that to work out my y values. So again, calculator out, using y equals 1.458. That tells you that, sorry, x equals 1.458. That tells you that y equals minus 3.416, and x equals minus 4.458. That tells you that y equals 8.416. Now, because I've used only 3 decimal places of accuracy, I'm going to I've shown all my working. The question doesn't tell me what accuracy to use. So I'm going to do 1 decimal place because I don't want to be too accurate given I've used rounded numbers. So it's going to be 1.5 against minus 3.4, and it's going to be minus 4.5 against 8.4. And then I'm going to say these are both to 1 decimal place. Now, most mark schemes will say anything that rounds to. So you can see what I've done. You can see my working. The examiner is expected to look at the working above, so therefore that should give me some flexibility. And that's the last question done. I'm quite happy with that today. A nice little mix of questions again. I do like these further maths questions. Do test your knowledge of just GCSE stuff, even if you're not doing further maths. As ever, do like, subscribe, and I'll see you for the next one. Thanks all.